All right, so I think I'm recording. Let's take a look at this problem. We have y equals the square root of 2x minus 5. We want to find the domain and range. We know that the parent function um, is the square root of x, and it looks something like this. So uh, let's let me back up. The domain is a set of all real numbers, excluding any values of x that cause division by 0. Well, I don't have any variables in a denominator, so I don't have to worry about that. I do, however, have a variable that's underneath the square root. So I am concerned that this expression 2x minus 5, I have to make sure it's non-negative. I have to make sure that that is 0 or bigger. So let's solve this inequality. Let's add 5 to both sides. Let's divide by 2. Half of 5 is 2.5. So my domain, let's draw it on a graph on a number line here. If 1, 2, 3, right here is 2.5. Okay, I need my values of x to be bigger than that. I need my values in my domain. If I want to have this x related to some y value, I need that x to be greater than or equal to 2.5. So if we call D the domain, and if we express this in interval notation, we have a bracket because it's okay to take the square root of 0. The square root of 0 is 0. So 2.5 is related to 0. We know that 2.5 comma 0 is a point on that graph. And we can pick any value of x that's bigger than this, and we can do that arithmetic, and we'll get a corresponding y value. We can't pick values that are smaller than 2.5. You try to figure out what 2 is related to. Well, 2 times 2 is 4, and 4 minus 5 is negative 1, and the square root of negative 1 is undefined, so we don't have, it's in the set of complex numbers, it's I. We're working with the set of real numbers, so 2 is not related to any value. To be in the domain, we need 2 to be related to some y value in the range. So we throw 2 out of the domain. So there's my domain for this function. Now, I can argue that I can figure that out also graphically because I'm familiar with what the parent function, the graph of it looks like the square root of x. I know what it looks like. So let me sketch that over here. I've got the square root of x that looks something like this. And I want to think about 2x minus 5. Well, oops. The square root of 2x minus, was it minus 5? Yeah. Well, the minus 5 is going to shift this 5 units to the right. So if this were 5, my graph going off like this would be y equals, well, let's back up a second. Remember, I'm building up towards this guy. Let's write it in a different color. Eventually, I want to show you what the graph of the square root of 2x minus 5 looks like. So far, I've only showed you what you already know, and that's what the square root of x looks like. Well, if this minus 5 shifts this graph 5 units to the right, and this graph is the square root of x minus 5. And so now, working with this resulting graph, this graph in green, if I put a 2 in front of there, that's a horizontal shrink by a factor of 1/2. So all of these x values get divided by 2. So this 5 comes over here. Half of 5 is 2.5. And the shape of it is still out that way. The distance, like from here, this x distance, the distance away from the y-axis has now been cut in half. Okay, so I know that I was correct when I figured out my domain being 2.5 to infinity. Now, for the range, we didn't lift the graph up or down, so it has the same range as the square root of x, and we know that that's on the x-axis or entirely above the x-axis. So from this picture, I know the range is from 0 to infinity. Now, if you don't like my picture, I went ahead and graphed it on that Desmos graphing calculator. And did I skip a problem? I may have accidentally, huh? You can see it got shifted over to the right, but it didn't get shifted up any. The y value here is 0, and every other point on here has a y coordinate that's greater than 0. So the range is from 0 all the way to infinity because these y values just continue to grow. All right, so let's go back and look. My range is from 0 to infinity. There's my domain and range for this problem number 3. I hope that helps.